We are starting 14.2, which is product of power property. The learning goal is I can generate equivalent expressions involving products of powers. So before we begin, I want you to do the warm-up, and then you're going to check your answer with mine. So to get the answer, we need to multiply -1/2 by itself 3 times, and then divide it by 1/4 times itself. So when we multiply -1/2 to the third power, we get -1/16 divided by 1/16. So then we have to do keep, change, flip because we can't divide fractions. So that gives us -1/16 times 16/1, and that gives us -1/1 because it was -16 over 16. And then that equals -1, and we want the absolute value of that, so that gives us a +1. I had a few questions about that one on the homework. All right, so let's get started with some vocab. First, we have the product of powers property. And so what this means is we are going to multiply the powers. To multiply the powers with the same base, we add their exponents. So anytime we have a base that is the same, we just add the exponents. So we keep the base and then add the exponents. So 4 squared times 4 to the third gives us 4 to the fifth. Then we have the power of power property, and to find a power of a power, we multiply the exponents. And so if we have 4 to the sixth, all to the third power, then we keep our base and we have 4 and then 6 times 3, which is 18, so we have 4 to the 18th power. So next we have power of product property. And so to find the power of a product, we need to find the power of each factor and multiply. So yes, you could multiply 3 times 2 and get 6 and then have 6 to the fifth power, but not always will there be 2 numbers in the parentheses. And so sometimes we'll have letters involved too. So we need to know how to do it. That way, if there aren't only numbers in the parentheses, we know what to do with that exponent. So what we do is we take the exponent and we are going to bring it through to both numbers. And so we get 3 to the fifth and then 2 to the fifth. And I'll give you some examples of what that looks like later. All right, so finding a product of powers, what we're going to do is notice that they both have the same base, so it's both a base of 2, so we're going to keep our base. And then we're multiplying 2 numbers with the same base, and so we are going to add our exponents. And so we get 2 to the 9th power. When there's not an exponent visible, we know it's actually just a 1. So this is actually -5 to the first power. And so we are going to keep our base -5. And this is 2 the 1 plus 6, which is -5 to the 7th power. All right, so then the last one, we have variables. And so the same rules still apply. The base is still the same. We still have a base of x. And then we add our exponents. And so we have 3 plus 7. And so we have x to the 10th power is our answer there. So I want you to try 1 through 3 on your own, and then you are going to check your answers with mine. For number 1, 2 plus 4 is 6, so we have 6 to the 6th power. For number 2, we have -1/2, and that's in parentheses, so we need to keep it in parentheses. And then to the 3 plus 6, so 3 plus 6 is 9, so we have -1/2 to the 9th power. For number 3, there's actually a 1 on that z, because that's just z times itself once. And so I put lines through my z's so they don't look like 2's, but we have z and then 1 plus 12, so z to the 13th power. All right, so now we're going to practice finding a power of a power. And so remember, when we're finding a power of a power, we multiply. So we're going to multiply exponents. So we keep our base, and then we're going to do 4 times 3. So we have 3 to the 12th power. Because what this means is I have 3 to the 4th 3 times. If we are multiplying with the same base, then we add the exponents. So 4 plus 4 plus 4, and 4 plus 4 is 8, plus 4 is 12, so that gives us 3 to the 12th power, and that's why this rule works. So again, this is 3 to the 12th power. So for this one, we have W, we keep our base, and then we're going to do 5 times 4, and 5 times 4 is 20, so we have W to the 20th power. So now you're going to try 4, 5, and 6 on your own, and then you're going to check your answers with mine. All right, so we have 4 to the 3rd to the 5th power, and so 3 times 5 is 15, so we have 4 to the 15th power, or the power of 15. So then we have y to the 8th power, because we have 4, which is 8. And then we keep our base, which is in parentheses, so we need to keep it in parentheses. So we have -4, and then 3 times 2 is 6, so we have -4 to the 6th power. All right, so now finding a power of a product. And so I kind of told you this earlier in the notes when we were going over vocab, but see, not everything can be multiplied together inside those parentheses. So even though that 3 and 2 up here could be, and we could have done 3 times 2 is 6 to the 5th power, we can't do that now because there's an x, and we can't combine something that has an x with something that's a 2. And so what we're going to do is take this 3 and we're going to distribute it to both things in the parentheses. So the 2 is now to the power of 3, and the x is now to the power of 3. Now let's simplify it. So 2 to the 3rd power, so that's 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, so we have 8x to the 3rd power, because we can't simplify x to the 3rd power. So your variable is always just going to keep the exponents. So now let's do this again. So we're going to distribute that 2 to all the things in the parentheses. So the 3 gets a 2, the x gets a 2, and the y gets a 2. And then we simplify. So 3 squared, so 3 times 3 is 9. And then we can't simplify our variables, so those just keep the exponents. So I want you to try 7, 8, and 9 on your own, and then you're going to check your answers with mine. Okay, so that 4 goes to both things in the parentheses, and so we have 5 to the 4th, and then y to the 4th. And so 5 to the 4th, or the power of 4, is 625, and then we can't simplify y to the 4th, so we just keep it as y to the 4th. So this is my answer, 624 y to the 4th. Then we have to distribute the 5 to the a and the b, and so it's now a to the 5th power and b to, or times b to the 5th power. And so that's our answer, because we can't simplify those. Make sure that you always keep it in alphabetical order. So like a needs to come before b, and then like x always comes in front of the y. On number 9, the m will come in front of the n. It's just proper notation for math. So then we have a half squared, and then m squared times n squared. So our answer is 25 hundredths times m squared times n squared. Alright, modeling in real life. So 1 gigabyte of computer storage space is 2 to the 30th power bytes. The storage details of a computer are shown. How many bytes of total storage space does the computer have? So you can see that free space is 16 gigabytes and total space is 64 gigabytes. So the number of bytes in a gigabyte we know is, oops, change my color, so 2 to the 30th times the number of gigabytes. So the number of gigabytes is 64, and 64 can be written as 2 to the 6th power, right? Because 2 times 2 times 2 times 2 times 2 times 2 equals 64. And the reason we're switching it to a base of 2, so that way it's the base of 2 to the 6th power, is because we want to use our rules, and so we can't multiply something that doesn't have the same base. So we have 2 to the 6th power is what the number of gigabytes is. And so then, now we can use our rules, so these both have the same base, it's a base of 2, and so this gives us a base of 2, and then we add our exponents, so 30 plus 6, so we get 2 to the 36th power. And that's our answer. Couple of things before I end the video. After this, go ahead and start your Big Ideas homework. It's 14.2. If you're wanting to retake your last test, please email me so that way I can assign you a new test, answer any questions that you have about your old test, and anything like that. So make sure that you email me for that. And then if you guys are wanting to do a live Zoom, just let me know, and we can schedule a time for that too. Alright, get started on Big Ideas.